The last video talked about bond prices and introduced the concept of discounts and premiums on bonds payable. This video is going to talk about what happens to a discount over the life of the bond. And I think discounts are a great way to illustrate what happens. Remember what a discount really is. A discount only exists because the embedded stated contract rate that's fixed in the bond contract is less than the prevailing rate of interest that's available to an investor in the market. So the only way someone's going to buy it, the only way someone can sell it, is if the issuer is willing to accept a discount. So in accounting, we call costs of borrowing interest expense. And this sounds a lot like interest expense to me. So the discount here is an additional cost of borrowing. The funds can only be borrowed if the issuer is willing to accept a discount in the first place. So what we do is we have to allocate the discount, this additional cost of borrowing, over the life of the bond. And there's a couple of ways to do that. This video is going to use the straight line method. Let's take a look. This is example 15-3. Assume a $1 million 4% 5-year semi-annual bond are priced at 98 and issued on January 1st, 20x1. Required, create an amortization table for the bond payable. Record all journal entries from issuance to the end of 20x3. In other words, the end of the third year. Before we address the required, let's make sure that we understand the background sentence that describes the bonds that are issued. The maturity value is $1 million. The stated rate of interest is 4%, which we can see here, a 1 million 4%. The number of periods, these bonds are 5-year semi-annual bonds, so that will be 5 years and 2 periods a year, for a total of 10 periods. And the bond price, the bonds are priced at 98. So the bond price will be 1 million multiplied by 98%, because the bond price is expressed as a percentage of maturity value, in this case 98%. Remember that the percentage sign is often dropped when discussing a bond price. Now that we have a good sense of what the maturity value, stated rate, the number of periods, and bond price are, we can begin to address the required, which once again is to create an amortization table for the bond payable. Let's begin with the column for the date. Next to that, we can have a column for the interest payment. Another column for the interest expense. We'll have a column for the discount amortization. A column for the discount balance. And the balance or the carrying balance of the bonds. We'll call it the bond carrying balance. The first date will be the date of issue. So that'll be Jan 1, 20x1. And on this day, we know that the bond was issued at a price of $980,000. So the carrying balance on the first day will be $980,000. And the opening discount balance will be the maturity value subtract the price, or $20,000. 6 months later, on June 30th, 20x1, there would be a payment of interest. Remember, the stated rate is 4%, but this is a semi-annual bond. So the interest payment will actually be the maturity value multiplied by the stated rate for the number of months in the year. In this case, it's a semi-annual period, so 6 out of 12 months. So each cash interest payment is going to be $20,000. In this example, we will use the straight line method to amortize the discount. The discount balance is $20,000, and we know that we have 10 periods over the life of this bond. This is an additional cost of borrowing that the issuer had to accept in order to sell the bond at all. So this $20,000 really represents interest expense that we are going to spread out over the life of the bond. Using the straight line method, we can take the $20,000 and divide it by the number of periods, or in other words, 2,000 a period. The remaining discount balance is $18,000, and the bond carrying balance is actually going to go up. Remember, it's $1 million, and we'll subtract the discount. This brings us to interest expense. Interest expense will be a combination of what was paid and the amount of discount that is being allocated to the period. And the discount represents a cost of borrowing or further interest expense. So the interest expense in this case will be $22,000. Let's take a look at December 31st, 20x1. We know what the payment's going to be. It's going to be the 1 million multiplied by the 4% multiplied by 6 over 12, or 20,000. Hopefully this stands to reason. Because we have a fixed stated rate of interest in the bond contract, the actual amount that's paid for interest is going to be fixed every period. We are also using the straight line method to amortize the discount. So that would mean that we can expect the same amount of discount amortization every single period. Interest expense will be the same. And once again, we will take the maturity value, subtract the remaining discount balance, and that will give us our carrying balance. I've gone ahead to complete the table, or at least the dates in the table, and we can check to ensure that I've done this correctly. We know that there should be 10 periods, so let's see how I did. 1 period, 2 period. Let's take a look at the third period, June 30th, 20x2. Once again, we can say that the interest payment is fixed and the discount that's being amortized is fixed. So we can really just drag this down. And let's pause to make sure everything makes sense. The interest payment is effectively 2% because we are taking a fixed rate of 4%, which is an annual rate, and the semi-annual portion, and the semi-annual rate would be 2%, which is $20,000 when multiplied by 1 million. The interest expense is a combination of what is paid and the discount that is amortized or allocated to the period. And the discount balance continues to decline because we are allocating a portion every single period. This means the bond carrying balance should be increasing. As the discount decreases, the bond carrying balance should increase. If we complete the table, let's see what we find. The total interest payment remains fixed over the life of the bond. The interest expense is also going to be a fixed number because the amount of discount that is being amortized each and every period is fixed. And the only reason it is fixed, it is because we are using the straight line method of amortization. Finally, the discount balance needs to be brought to zero by the end of the life of the bond or by the maturity date. And the carrying balance, if it is a $1 million bond, it should be $1 million by the end of the life of the bond. Let's consider the next part of the question. We are asked to record all journal entries from issuance to the end of 20X3, or the end of the third year. The first date would be January 1st, 20X1, when, from the point of view of the issuer, cash is received. How much cash was received was $980,000. That was the price of the bond. The issuer has an obligation, bonds payable, for the maturity value, and the maturity value was $1 million. Finally, we have to recognize the discount on bonds payable, which is $20,000 on day one. Moving along to the first interest payment, or the first semi-annual period, June 30th, 20X1. We would recognize interest expense. This is the cost of borrowing. It's $22,000. We know that a portion of that cost of borrowing actually happened near the beginning, but we are recognizing only a portion of it each and every period. That would be the discount. The discount on bonds payable is a normal debit balance. In order to reduce it, we reduce it with a credit. Finally, the other portion of this interest expense was paid out in cash. And that was this payment right here in period 1, $20,000. You can probably see that I just took these three numbers here that are highlighted right off of the table to help me complete the journal entry. And I'll do the same for the next transaction. On December 31st, 20X1, the transaction is going to look the same. I'll have the same accounts and the same amounts, but I would take them from here. So interest expense was there. The discount on bonds payable is $2,000, and the cash paid is $20,000. The question asks you to do this all the way to the end of 20X3, right there. But the journal entry is actually going to be the same. You'll just be taking the numbers from a different portion in the table, but effectively it doesn't matter. It's the same numbers. What you might find a bit more interesting to do, even though we are not asked to do it in this question, is what would the entry be at the end of the life of the bond on December 31st? So why don't I take some time to show you that? Well, let's skip ahead. And on December 31st, 20X5, we'll have two entries. One entry will look the same. You're used to seeing it. The interest expense would be the $22,000. The discount on bonds payable would be a credit of $2,000. And the cash would also be a credit of $20,000. But we know at the end of the life of the bond, the issuer must settle the bond with the maturity value. So we can now derecognize or settle the obligation of bonds payable, which was $1 million. We debit bonds payable $1 million, and we credit cash for $1 million. In our next video, we'll look at another method for allocating a discount or a premium on bonds payable, and it's called the effective method. But until then, I hope the example we did in this video was helpful to you. Thanks for watching, and I'll see you next time.